sorry, similarity, right? So similarity means there has to be two criteria which needs to be fulfilled. First of all, angles are equal. Clear? Like
Yes, ma'am.
if we specifically talk about triangle. Okay. So angles are equal in both the triangles. Obviously, there are two triangles which we are trying to make similar, and the sides are in proportion. So based upon this concept, there was exercise 6.1, right? Okay. Now, second exercise, basically, when we came to exercise 6.2, so that we studied basic proportionality theorem. So basic proportionality theorem means that if the two triangles are similar, right?
Yes.
What was the theorem? What was the statement?
If a line is drawn parallel to one side of the triangle, then the other side intersects the other line on in distinct points, then the other side is divided.
Yeah, so it was not about like two triangles, only single triangle was there. And then if a line which is drawn parallel to third side, so if this is your ABC and the line is actually PQ. So if we draw the line PQ parallel to BC, so by the theorem, your AP upon PB should be equal to AQ upon QC. So that was the theorem, right? Okay. Now we come
Yes.
to, okay, when we come to exercise 6.3 now, what will happen here? We will show, like there are some theorem. Now, what is what is a theorem? What do you understand by the term theorem?
Rule.
Yes, theorem, see, theorem is something which is already proved, by, many times it has been proved. If you use that, so always it will give the same result. So it is like universally proved. All right, that then it becomes a theorem. So that means you can directly use the result. It is already proved so many times. Getting the point? Okay.
Yes, ma'am.
But you are studying it for the first time, so we will show, like we will prove it once and then we will show. So the theorems are basically, it says that the first theorem, if we talk about, okay, first of all, very quickly, I just want to tell you what it is. There are two criteria. One is about the angle and the other is about the sides for similarity, right? Now the theorem is that it says that if you show that only the angles are equal, that means in two triangles, if angles are equal, then this is triangles are similar. All right. That means if the
Yes.
angles are equal, so ultimately the sides are going to be in proportion. Sides will be in proportion. So this is a theorem which you can use. So this condition is actually called A criteria of similarity. Hello, Hamna.
Yes, ma'am.
Yes, Hamna, can you hear me now? Just a minute, Ridash is trying to join. Okay, anyway, so we will only show that the angles are equal, and by A criterion, the triangles will become, similar. Similarly, we have SAS criteria and we also have SSS criteria. Getting it? Okay. And has she joined? No. Okay, so let's do the first theorem, then we will do it one by one. So theorem 6.1, I'll also do the proof. First of all, write down the statement that if a line is drawn, oh, sorry, this is 6.1. I have to do 6.3 now. Just a minute. Yeah, this is the theorem that if in two triangles, corresponding angles are equal, yes, Hamna, can you hear me? Then the corresponding sides are in the same ratio or proportion. And hence the triangles are similar. Yeah, please write it down, Rida. Hamna, can you hear me now?
Yes, ma'am.
Okay, so you were late, Hamna. Please note down this theorem, then I'm explaining it.
Okay, ma'am.
Yes, written?
Yes, ma'am.
Okay. So Hamna, what I was explaining it, Rida, you also listen now. Again, we come to, for example, you have studied about congruency, right? So there were many criteria to prove that the two triangles are congruent. One was AAA, then we have SSS, something was SAS and ASA, RHS, etc. Right? Using these criteria, we say that the triangles are congruent. Now, similar again for similarity also, if we want to show that the two triangles are similar, there are actually certain criteria. One is AAA, then one is ASA, then other is SSS. So these three criteria can also be used to prove the triangles are similar. Now, again, one more thing. In exercise 6.1, when we were doing Hamna, so we say that if the two triangles are similar, so there has to be two criteria which needs to be fulfilled. First was about angles, that the angles should be equal, and the second was about sides, that the sides has to be in proportion. Getting it?
Yes, ma'am.
Yes. Now, but there is a theorem now which says that if in two triangles, corresponding angles are equal, so only angles are equal, right? Then the corresponding sides are in the same ratio. So that means in two triangles, ABC and PQR. So if all the angles are equal, that means angle A is equal to angle P, and angle B is equal to angle Q, and angle C is equal to angle R. So it is a theorem that ultimately the sides are going to be in proportion, right?
Yes, ma'am.
Okay. And when the two things are satisfied, that means the triangles are now similar, and hence the triangles are similar. Understood, Rida?
Yes, ma'am.
So it's a theorem that if all the angles are equal, so then the sides are also in the proportion. And because the two conditions are not satisfied, so therefore the triangles are similar. So if we want to prove the similarity criterion, we will try to show that all the angles are equal. So if angles are equal, sides are in proportion, and triangles are similar. That's it. Now I'll do a proof of it. Let's do the proof. So just, I mean, this was just something, I don't note it down. Write down the proof of this theorem. So we will show that the sides are in proportion, right? So we take two triangles, similar. Right now they are not similar. We will A, B, C, and then I'm taking another triangle. Let's say D, E, F, right? Okay. Now what is given here? The given thing is this, that all the angles are equal. So angle A is equal to angle D, angle B is equal to angle E, and angle C is equal to angle F. That is given. And what you have to prove that the sides are in proportion. So AB upon AD, sorry, AB upon DE, it should be right, not AD. Sorry, AB upon DE. Yeah. This should be equal to BC upon EF, and it should be equal to AC upon DF. This you have to show. So we will do one construction here. Construction is that this much length AB, right? The length of AB, we will use this length here and we will make a point. So let this point is P, and similarly AC length we will cut here. Let this point is Q, and then we join PQ. All right. So construction is this, that DP is equal to AB and DQ is equal to AC, and then join PQ. So this much is your construction. Any confusion so far?
No, ma'am.
Okay, let's do the proof now. Okay. Now, if we take these two triangles, in triangle ABC and triangle DPQ, yeah, the small triangle, so both the triangles, can we show they are congruent? See, okay, what I'm trying to do is, it is given that angle B is equal to angle E, right? So this angle is equal to this angle, right?
Yes.
But I want to show that angle B is also equal to angle P, because I want to make this triangle similar to this small triangle. So I want to make this angle is equal to this. So if I prove that these two triangles are congruent, then by CPCT it will be equal. Yes.
Yes.
Okay. So let us try to prove them congruent. Yes, Hamna. Now what can I use? Congruency you all have studied here. Which criteria of congruency I can use here? There are so many, right? AAA, SAS, then ASA, SSS. Which one can I use here?
Ma'am, SAS.
Okay, why? Tell me three conditions.
Ma'am, DP is equal to AB.
Okay, very good. So first I'm writing ABC. So AB is equal to DP. How? By construction. Yes, Frida? Because I've
Yes,
constructed
ma'am.
them to be equal. Okay. Now second, again, AC is equal to DQ. Again, by construction. Okay, what else?
Ma'am, angle A is equal to angle D.
Very good. It is given. So the three conditions are satisfied. So which criteria now? By, yes, SAS. So by SAS criteria, these two triangles are congruent. ABC is congruent to triangle DPQ, right? Okay, and by CPCT now, my angle B is equal to angle P. So this I wanted to show. Okay, one thing. Now, angle P is, okay, now since these two lines are parallel, no, angle, yeah, okay, angle B is equal to angle P, okay, and angle B is also equal to angle E. Yes, this is given. So from these two, what can I conclude? That angle P is equal to angle E. Yes, hence.
Yes.
Okay, so therefore, angle P is equal to angle E. Right. Now, if these two angles are equal, I mean, this is the triangle. I'm just drawing it here. And this is PQ and this is DEF. Right. Now, if these two angles are equal, so can I write that PQ is parallel to EF? Yes, Hamna, can I write this? Which type of angles these are?
Ma'am, corresponding.
Corresponding angles, right? Since corresponding angles are equal, so therefore the lines are parallel. Corresponding angles are equal. So therefore the lines have become parallel. Okay, so if lines are parallel, so can I use basic proportionality theorem here? Right?
Yes, ma'am.
So since now my line PQ is parallel to EF, so by BPT, applying BPT, so basic proportionality theorem, okay, your dP upon PE, sorry, is equal to dq upon qf. So far, any confusion? Okay, so I'm just scrolling it. I hope you have written, both of you.
Yes.
Okay, now just some calculation we will do here. I'm just reversing it, no issue. So I'm just flipping it. So PE upon dP is equal to QF upon dQ. Yes. Okay, so then if I add 1 on the both sides, so what will I get? So if I add 1, so PE upon dP plus 1 is equal to QF upon dQ plus 1. This I'm doing, right? Now take LCM. So dP is equal to, so this is PE plus, I'll get dP here. Yes. If you have any confusion in any step, please tell me. Yeah, Rida, any problem here?
No, ma'am.
Okay, because I have 1 in the denominator, so that will be multiplied by dP and that dP will go in the denominator. So I'll have it like this. Now what is PE plus dP in the diagram? Please see your diagram.
Ma'am, DE.
DE, the complete side DE, right? DE upon dP. Similarly, QF plus DQ is how much?
Ma'am, DF.
DF, your complete side DF upon DQ. Okay, now again I'm flipping it. No, before flipping it, I can do one thing here. Now DE is equal to AB, right? And DF is equal to AC. So can I substitute? So AB upon DP, can I write?
Yes, ma'am.
Okay. AB upon, sorry, what have I written? AB upon DP. Wait. What I have got ultimately is DE upon DP is equal to DF upon DQ. All right. No, not DE is equal to, what was the diagram? Sorry, this was, I just forgot the diagram. ABC, right? And this was another triangle. So DPQ and then E and F. So basically DP is equal to AB, not DE. So DE upon AB will come here. Yes. This DP is equal to AB. See the diagram? And this is equal to DF upon, now this DQ is actually equal to AC. So I can write AC here. Is that okay now?
Yes,
Okay,
ma'am.
now I'm just flipping it again. So AB upon DF is equal to AC upon DF. Sorry, this was DE and this is DF. Yes. So this is actually, by construction it was that DP is equal to AB. You can write in the side DP is equal to AB and DQ is equal to AC by construction. Anyway, this is already written in the construction. So I have got this thing. Now what can I conclude from here? Yes, Rida, any confusion so far?
No, ma'am.
Okay, so this condition, now similarly, we can also show. So we will not do it again. We will write similarly. We can show that AB upon DE will be proportion to the other side. That is your, BC upon EF. So far we have shown that AB upon this is equal to AC upon this, right? We can also
Yes.
show that AB upon this side is equal to this upon this. I mean, the third one which is remaining. So we will write similarly. So now if we compare the three results, we will get AB upon AD is equal to BC upon EF will be equal to AC upon DF. So the sides are now in proportion. So we have proved that if all the angles are equal, then ultimately the sides are going to be in proportion. So from now on, we will use it as a theorem. Is that okay?
Yes, ma'am.
Okay, so this criteria is actually called AAA criteria. Got it? I mean, you have to write this thing here in the theorem statement. So this is actually your AAA criteria. You can note it down. Yes, Amna?
Yes, ma'am.
Okay. So have you noted, both of you?
Yes, ma'am.
Okay, now there's one thing to understand here. This AAA criteria can also be reduced to AA criteria only. Because if you have two triangles, let's say any two triangles, right? If two angles are equal, third angle is going to be equal ultimately. Why?
Ma'am, because of the angles and property.
Angle sum property. Yes, Rida.
Yes, ma'am.
Why they will be equal? Tell me.
Some property.
Okay, for example, this is 60 and this is okay, this is 60 and 80, right? So what is the value of the third angle? Tell me, how much is angle X?
40.
40. So how you got it? 180 minus 140, right? So you get 40.
Yeah.
Very good. So this is 40 degree X. Similarly, like if the two angles were equal, so this is 60, this is 80. So again, in this triangle also, it is going to be 40 degree. Clear? So that means you don't have to prove all the three angles. Proving only two angles is also sufficient, right? So
Yes,
this
ma'am.
AAA criteria can also be used in place of AAA. So this you have to understand. Now there are two others. I think I will not prove them, but you should write the statement. Or we can see, let's see. Theorem 6.4 now. If in two triangles, let us understand the statement. If in two triangles, sides of one triangle are proportional, So this criteria is called SSS similarity criteria. It is saying that if in two triangles, sides of one triangle are proportional to the sides of other triangle. That means this time the sides are given to be proportional, then their corresponding angles are equal. So we can, I mean, this is a theorem that if sides are proportional, the angles are ultimately going to be equal. All right. And hence the triangles will be similar because the two conditions will be satisfied. So this is called SSS similarity criterion. Should I do the proof or should I leave it now? Anyway, it's very simple. Okay, that's your homework. I think because this is proof is already given in your NCERT book. Both of you will just go through the proof, and in case you don't understand it, then we can do it. All right. You just note the theorems. Just give me a minute. Yes, please note down the other one also, then we will start the exercise. So there's one more theorem. Theorem 6.5. Now what does it say? If one angle of a triangle is equal to one angle of the other triangle, and the sides including these angles are proportional, then the two triangles are similar. To understand one thing here in this theorem, if one angle of a triangle is equal to one angle of the other triangle. So if you have two triangles, let's say, right? This is your triangle ABC, and this is your triangle, let's say DEF again. And again, I have drawn one PQ. So this much is clear that AB is equal to DP and AC is equal to DQ, like that. So if one angle of a triangle is equal, so let's say angle A is equal to angle D, and other okay, and the sides including the angle. So that means this side has to be equal, AB and AC, not the BC one. So in this case, similarly, your DE should be, sorry, DE is equal to DF, like that. So the the angle formed between these two lines, and similarly the angle formed between these two lines both are equal, and these two sides are equal, then the triangles are similar. So this criteria is also known as SAS. Understood? So these are the three criterion for similarity of triangle. Let's do exercise 6.3 now. And please go through the examples also in case you don't understand any of the examples, so then we can do. Otherwise, I'm leaving that for you. Now 6.3, please see in your book, state which pair of triangles are similar. Write the similarity criterion and also write the pairs of similar triangle in the symbolic form. Okay. So here you need to understand one thing. Yes, Hamna.
Yes, ma'am.
Okay, so the first one, which criteria should I use here?
Ma'am, AAA.
AAA, okay. Just give me a minute. I'm inserting some pictures. Yes, Rida, are you here?
Yes, ma'am.
Okay, exercise 6.3. Now come to the first question, first part. So which criteria of similarity you will use here? So write it properly that your angle A is equal to angle P and angle B is equal to angle Q and angle C is equal to angle, angle R. So which criteria? A criteria. Now, how will you write similarity? That triangle ABC will be similar to triangle PQR. Again, this is something you have to note. For example, in congruency also, if I write triangle ABC is congruent to triangle PQR, right? And sorry, something happened here. Yeah. And if this is by AAA criteria of congruency, so that means this implies that angle A is equal to angle P. Getting the point? I mean, I cannot write it like this, that triangle ABC is similar to triangle QPR, not like that. The corresponding angles I'll write equal. Getting the point here, Hamna? Please speak up. Okay, listen to me again. Yes, Rida, are you here?
Yes, ma'am.
For example, you have two triangles. Okay, try to understand it again. This is your angle A, triangle ABC. This is your triangle PQR, right? Now, situation is this, that angle A is equal to angle R, let's say. And angle B is equal to angle P. And angle C is actually equal to angle Q. Thing is like that. Now, because AAA criteria is now satisfied, that means the triangles are similar. So I'll write them like this. If I write triangle ABC is similar to triangle PQR, so this will be wrong. Okay, this is a wrong way of writing. I'll write the corresponding angles accordingly. So triangle ABC. Now, which angle is equal to angle A?
Ma'am,
Angle R. So I'll start with R. Then which angle is equal to B? So angle P. And which angle is equal to C? Angle Q. So this is the correct way of writing. Understanding?
yes, ma'am.
Okay, so that you have to note clearly. Similarly, I'll come to side also. There's a way to write the sides also in proportion. When you're writing sides in the proportion, then also you have to be careful. Now come to question number 2. Okay, this is the figure. So which criteria should I use here?
SSS.
SSS. Okay, that's good. So, okay, now again, what is the method of writing? Now, since you are checking that AB upon, what was that?
QR.
AB upon QR. Okay, so that is equal to 2
2
by
by
4.
4.
That is 1 by 2. All right. Now, AC upon PQ.
PQ.
Right. So this is 3 by
3
6.
by 6.
This is also 1 by 2. And similarly, your BC upon PR is also 1/2. Yes, Amna? Okay. Now, how will you write it? So there's a way of writing it. Please note down.
ABC similar to QRP.
QRP. Yes. Okay. See, you write it like this. If you are starting with AB, okay, leave the third one, is similar to triangle. Now, which side is proportion? QR. So you will use QR here. Sorry, QR, right? And then put the third one. C and then your P. Clear, Amna? So this means that AB is proportional to QR. Clear? And BC is in proportion to RP or PR. And then your AC is in proportion to QP. That you can see here. Yes, AC is in proportion to PQ. And then AB is proportion to QR. And then your BC is proportion to PR. Getting the point here? How to write? Yes, Hamna.
Yes, ma'am.
Getting it? How to write it?
Yes.
Yes, Rita, any problem here?
No,
Okay, right. So then come to the third one. Now tell me which triangle is proportion to which triangle. Sorry, similar.
it's not similar.
Yes, it's not similar because if I do, for example, MP upon DE, so that will give me 1/2. Similarly, this side is proportion to this, but the third one, 2.7 is not in proportion to 5, right?
Yes,
So
ma'am.
these triangles are not similar. Now come to the fourth one. Are they similar?
Yes.
Yes, ma'am.
Which criteria?
Okay.
SAS.
SAS. Okay. Now next one.
Not
Okay.
similar.
Okay. Now fourth one. How will you write the fourth one? Please tell me which triangle is similar to which triangle. How to write it?
Triangle MNL similar to triangle QPR.
Triangle QPR. No, that's wrong.
Ma'am, QRP.
PQR.
Mm,
Ma'am, triangle MLN is equal to, similar to QRP.
QRP.
Triangle NML similar to triangle PQR.
MNL. PQR.
NML
Okay, let's see.
similar to PQR.
Okay, there are so many responses. So let's see what is the condition here. So angle M is equal to angle Q, right? Now which sides are in proportion? So MN upon PQ, right? PQ. Okay, so this is actually equal to 1/2. Then again, I have my ML upon which side now? QR. This is equal to again 1/2. Clear. So can I put this angle M in between the two sides?
Yes.
Okay, so if I write like this, the triangle MN, I'm starting from this. So, okay, let's not put it in between. So if I start from MN, then similar to triangle, so PQ. Okay, so I should start with PQ here and then write the third thing. So MNL and will be similar to PQR. Is that okay? Now MN will be proportion to this. Okay, and then your ML will be in proportion to PR or QR.
QR.
Oh, there's some confusion again. Let's write it again. Yes, Hamna, how to write it? Please help me out. Okay, if I start from this, let's say I'm putting the angle in between, right, will be similar to triangle if I put the angle in between Q. So what is the side corresponding to NM? It is PQ. So can I write P here? And then ML will be QR. I think this is fine now. Right? So this means this angle is equal to this angle, the middle term. And this side NM is proportional to PQ. This is right now. Yes, Rida?
Yes, ma'am.
Okay. Now come to fifth one. So first of all, write down angle A is equal to angle F. Okay. Now which side is in proportion? So AB is proportional to DF here, which is again 1/2. And the side BC is actually proportional to EF, which is again 1/2. Now how will you write it? Now you will tell me.
They are not similar.
Yes, Hamna, are they similar?
Yes, ma'am. No, ma'am. No,
No. Why no?
ma'am, because
See, this is actually wrong. I have written. First of all, you just in the third theorem, you have seen that these sides should be the one where the angle is included, right?
yes, ma'am.
So in triangle ABC, A, B, and C, so this side is given 2.5, but this side is not given. It is actually this side which is given. And the other triangle, these two sides are given. So basically they are not in, the sides are not in proportion, not similar. Clear?
Yes, ma'am.
Okay. Sixth one, are they similar?
Yes.
Yes, they are. So ultimately your angle F will come out to be how much? 30 degree. Sorry, 180 minus how much? It will be 30 degree, right? And
Yes.
angle P, if you will find out, it will come out to be 70 degree, like angle sum property you will use, angle sum property. Now you compare. So angle D will be equal to angle P. Angle E is equal to angle Q. And angle F is equal to angle R. So how to write it? Triangle DEF will be similar to, sorry, not congruent, similar to, which angle is equal to D? P. So PQR.
QR.
Yeah. So just be careful, like while writing the triangles. Okay, let's do question number 2 now. So you can read the question in your book, both of you. Now in figure, this is the figure. You have something like this. Okay, DC and ABO. So this angle is 70 degree and this angle is 125 degree. Okay. Angle ODC is similar to what is given here, that triangle ODC is similar to triangle OBA. Okay. And also one angle BOC is 125 degree. Angle CDO is equal to 70 degree. Now what you have to find? To find angle DOC, right? And angle DCO and angle OAB. So let us mark them. DOC is which? This. So let us, this be angle X. DCO. DCO. So this Y you have to find. And OAB, that means this. Let me call it Z. So DOC, I have taken X, DCO Y, and this is Z. Just, to make the writing a bit easier. Clear? So let us find out the solution. So first of all, tell me, what should I do? Any idea? Angle X is very easy to find. How can I find it?
(180 minus 125).
Exactly. It's a linear pair. Yes, Hamna? Angle X plus 125 degree is equal to 180 degree. It's a linear pair. So angle X will be 180 minus 125. How much?
55.
Yes. So angle X is equal to 55 degree. Now in triangle DOC, two angles you know, the third one you can find. Yes.
Yes.
So how much is angle Y? Angle Y will be 180 degree minus angle X is 55 and minus 70. So tell me angle Y is equal to how much?
55.
Again 55 degrees. So X and Y we have found out. Now angle Z is remaining. So any idea what can I do here? Think about it, Hamna. Please tell me what can I do here? See, make you
Angle DCO is equal to angle OAB.
OAB. Why?
Because triangle ODC similar to triangle OBA is given.
Exactly, it is given. Yes, Hamna. So make use of the given condition. The triangles are similar, so the corresponding parts are also equal. Yes.
Yes.
Yes. So since your triangle ODC is similar to triangle OBA, and what can I write here then?
Angle DCO
OD,
is equal
okay.
to angle OAB.
ODC. Yeah, angle DCO. That means your angle Y. Or you just simplify. Angle Y is equal to angle Z. Isn't it, Hamna? Oh, okay. We write it like this. Okay, just to avoid mistakes. See here. Which angle I'm interested? The C one. So which is coming here? A. Yes, Hamna. Noted. Hamna, I'm not able to hear you. Please unmute yourself. All right. If this condition is given similar, so that means this first one is equal to this angle, which is actually the common angle, right? So angle D will be equal to angle B and angle C will be equal to angle A. So where is it falling? I mean, this angle will be equal to this angle according to the triangle. Good. All right, Hamna. So angle DCO is equal to angle OAB. Yeah, that's so angle 55 degree will be equal to angle OAB. So that's you were supposed to find. Yes. So rest of the questions I think I'll take up in the next class. I hope this chapter will get over in the next class. And then, okay, when is the upcoming exam? Any exam, Rida, are you having? I think you told me. I've just noted it
Sunday.
down. Let me check. Which chapter is coming? Sunday?
Sunday I have social exam.
26 you are having your exam.
Max.
Maths exam. So triangles will be over by then. and the other chapter you have already done. We can have a revision before your exam.
Yeah.
Okay. Oh, I'm going to give you some tests, so you will be notified. One by one, I think I'll take revision of all the chapters. Okay, Hamna? You had your exam, I think, day before yesterday? I think she has left. Okay, Rita, I think you can leave now. Okay, bye. Sarah, you are here?
Yes, ma'am.
Okay. Sorry, I thought it was Hamna. I was calling her. Okay, Sarah. So what were we doing in the last class? We were doing linear equations.
Yeah.
So how was the exam?
It was actually good, but actually the exam was like totally out of syllabus, you know, and like even toppers couldn't do that much nicely.
Oh, see, can you share the questions with me?
Yeah, I can right now.
Yeah, please. Yes, Sarah, are you sending me? Yes, Sarah, are you here?
Just 1 minute.
Okay, I've got it. Yes, Sarah, can you hear me?
Yes, ma'am.
See, Sarah, actually, it's not out of syllabus, but did you solve both the assignment sheets for the exam?
Not both. I did one and also half.
Yeah, that is why. I mean, these kind of questions were there in your assignment
Ma'am, but
sheets
everyone
also.
did. Everyone did so many, like even the toppers did, but they couldn't, like, solve those questions and very
Yeah,
difficult.
this case-based question I understand, because I think you have not done this type of questions, case-based. See, that's why I was saying, Sarah, just, doing NCRT is not enough for class 10th. Getting the point?
Yes, ma'am.
NCRT is actually, a reference book. Basically, it tells you which chapter you have to prepare for your exam and what are the, concepts you need to prepare for the exam. And for the questions, you have to refer to other books also, right?
Yes, ma'am.
And then, you have to complete a chapter, I mean, much before your exam, so that you get enough time for your practice. And if you are studying the exam, just 1 or 2 days before the test or exam, so you will not get enough time for extra questions. Getting my point?
Yes, ma'am.
So that's why, I mean, you have to finish the syllabus on time, and then you have to devote at least, 2-3 classes just for revision for every chapter. Okay, anyway, I'll just, go through it properly, and we will discuss in some other class, because your test is already over. So which chapter so far we have done, Sarah? Now, quick revision. We have done real numbers, right?
Yeah, real numbers and then polynomials and linear equation with into variables. And now and arithmetic progression.
Arithmetic progression, I've
We
stopped in
didn't it for
between. Yeah, just, starting we have done. Okay.
And then now we were doing triangles.
Triangles. So I've started with you, right?
Yeah.
How much we have done with you?
Just the introduction.
Exercise 6.1, was it over?
No, we didn't
Okay.
start it.
Okay. So triangles, again, let us start with the triangles chapter now. Basically, in your class 9th, as I told you, there was a chapter which is called congruency. Okay, I just gave you a small introduction, just introduction. So congruency, and then there is another term which is called similarity, right? Okay. So congruency you have studied. Congruency means what? That there are different criteria of congruency. That means AAA, that in two triangles, if all the three angles are equal, then the triangles are congruent. Then ASA, that means if two angles are equal and one side is equal, then the two triangles are congruent. Then SAS means two sides and one angle. SSS, that means all the three sides are equal in length, then the triangles are congruent. Clear?
Yes, ma'am.
Okay, and one is another RHS. I mean, one of the angle is actually 90 degrees. So these kind of triangles. So these were the criteria for congruency. And congruency means angles equal and sides equal. So the important thing was equal. I mean, they have to be equal. Now, if you talk of similarity, there are two criteria which needs to be fulfilled. That the angles are equal, right?
Yes, ma'am.
Okay. The second criteria is sides are in proportion or in same ratio, we can say. So this, yes.
Do you think in like if I inshallah pass in 10th, I think I should be taking standard maths?
Which class?
In 11th.
Standard, you can take, Sarah. I mean, first of all, Sarah, you have to fix your time. Like daily, you are devoting 1 hour at least to mathematics. If you think you can devote, I mean, very punctually, then go for it. No problem. right? You see, you have to be very regular with your practice. When I was in class 11th and 12th, you know, every day I used to solve at least 3-4 exercises in one day. I used to solve, I mean, from other book, obviously not from NCRT, some other reference books. So, I mean, I made sure that every day, you know, without skipping any single day, I devote at least 1 or 1.5 hours to my mathematics practice. And then it becomes very easy and very interesting. Yes.
Yes, ma'am.
So are you interested in taking science in class 11th?
Yeah.
You can take it, Sarah, but you know, you have to be just, first of all, regular with your studies. You can't skip. In class 11th and 12th, you have a lot of syllabus to complete. So you have to be very regular. At least, you know, one day you will study physics, next day chemistry, or, you know, all the subjects in one day. But you have to be, you know, you have to devote time to your studies. That's it.
Yes, ma'am.
Yeah. So you have a full year, Sarah, class 10th, just, it has just started. My advice is, please make your timetable, just fix 1 hour that this is the time I'm going to devote to my mathematics practice. That's it. And use, I can give you some books to, do you use RD Sharma there?
Actually, my previous sir said like RD Sharma is very hard and it's very extra.
Yeah, it is extra, okay, but extra means it gives you a good practice. You know, it has a lot of questions. If you know, sit and start solving some questions, so you know, when you start solving the questions, the concept is actually, you know, it get fixed in your mind. Getting it? In
Yes, ma'am.
NCRT, you have only 2 questions on one concept, so you can easily forget it. But if you are doing 20 questions just on one concept, you will never forget it, right?
Then what about I have like two
Hmm.
reference books.
Which one?
One is Together With, and second was I don't remember the name. I've never used it actually.
Sorry, YouTube.
No.
So
Together With.
Together With, yeah. And what was the other one?
I don't remember the name because I never used
Okay,
it.
okay, okay. Any book you can take, Sarah, no problem. Actually, they all have similar kind of questions, whether you use R.D. Sharma Together With or R.S. Agarwal, you know, there are others also. They basically include previous year questions, with the questions which have already, you know, occurred in your board exam in last 10 to 15 years. So they come, like uh, they give you those questions and they design their own questions, similar questions. So any book you can take, it will give you a good practice. If you have Together one, go for it. It's good.
Okay, ma'am.
Yeah. Every day, just make sure that you will finish one exercise from Together With, because you know, they have a lot more questions than NCRT. So
Yes, ma'am.
yeah, you will see, Sarah. I mean, personally, I was also scared of maths when I was in school. You know, there was a particular year I got bad marks, seriously. But then I realized that it was my mistake. I was actually not devoting time to my maths, and then I was complaining it is hard and it is this and this is this. And then I started giving it time, and you know, I topped in my class in the next few exams. So it's not hard, Zara. Just it requires some time.
Yes, ma'am.
Okay.
Thank you
So
for the advice.
yes. So please make sure that you are solving every day. You are solving questions from Together. So the concept will actually fix in your mind. It will give you a good practice. And this case-based questions, I think if I'll try to find more case-based questions, we can discuss them in some of the class. In some revision classes, we can do it.
Yes, ma'am.
Okay. So anyway, similarity. So come back to similarity. So have you understood the difference between congruency and similarity?
Yes, ma'am.
Okay. So congruency means same shape and size. Okay. And similarity means same shape. So shape has to be same. That means if the two triangles are congruent, so they have to be like they both have to be triangle first of all, right?
Yes,
Same
ma'am.
shape and same size also. I mean, this side should be equal to this side. This side should be equal to this side, and this side should be equal to this side. So then they are congruent. So same shape and same size. But if they are similar, So shape has to be same. Like this is one triangle, this is another triangle. Sorry. So shape is same, but the sides are in the same ratio. They have to be in ratio. For example, the side is 2 and it is 5 times. So this side is 10, right? If this side is, for example, again 2, so this also has to be 10. If this is 2, this is also 10. So the sides are in proportion. Getting my point?
Yes, ma'am.
Okay. Or if the triangle looks like this, I mean, it's an equilateral triangle I have taken. If I'm taking a scalene triangle, that means the 3 sides are unequal. For example, like this I'm taking, right? So another triangle will be like this. Okay. So if this side is 2, let's say this is 3 times bigger. So 2 into 3 is 6. This side has to be 6. If this is 3, so 3 into 3, this side has to be 9. If this is 4, so this side has to be how much? 12. So like every side is multiplied by 3. Clear?
Mm.
So these two are similar triangles because the angles are equal. This angle is equal to this angle. This angle is equal to this angle. And this angle is equal to this angle. So this is given. And the sides are in proportion. That means if you take the ratio, for example, this is ABC and this is PQR. So understand what is proportion means. So if you take the ratio, for example, you are doing AB upon PQ, right? So what will you get? 2 upon 6, that is 1 upon 3. Clear?
Yeah.
Okay. So let's take other side. So if I'm taking AC upon PR, so this is 3 upon 9. This is again 1 upon 3. And if I take BC upon QR, so this is 4 upon 12. This is again 1 upon 3. So you can see every time I'm getting 1 upon 3, 1 upon 3, 1 upon 3. So my sides are in the same ratio. Getting the point? What
Yes,
is same ratio means? Okay. So if these two criteria are satisfied, that all the angles are equal and the sides are coming out in the same ratio, then the two triangles are similar. Okay.
Yes, ma'am.
Now how to write it? There's one thing which you need to understand. For example, when I talk of congruency, let's say this is ABC, clear? And this is PQR. And they are congruent. Congruent means same angle, same side. So if I write triangle ABC is congruent to triangle QPR, is this correct? What do you think? See, this is also a triangle, this is also a triangle. So can I name it simply anything which I wish? No, it's wrong.
No, ma'am.
Why wrong? Tell me.
Because it should be like same. Like ABC, it should be PQR.
Exactly, because this angle is equal to this angle, right?
Yeah.
So if I'm writing A here, so the first has to be P here. Okay. Then this angle is equal to this angle. So if I'm writing B second, then it has to be Q second. And
Yeah.
then the third one. So this is the correct way of writing. Similarly, in the in the similarity also. Now how to write it? Okay, now how to write it? For example, if you know the angles, so by angle it becomes easy to write, right? Angle A is equal to angle P, so that means, triangle ABC will be similar. This is the sign of similarity, will be similar to triangle PQR, right?
Yes, ma'am.
Okay, but if you don't know the angles, what will happen then? Let's say you don't know that the angles are equal, but you know these sides are in proportion. So how will you write? So you will write like this. Okay, I'm telling you, pick up the first any ratio. Okay. So write it like this, two triangles, similarity sign. So first one AB, and then here PQ will come. Getting it?
Yeah.
And then the third one. So C, and here you have R. So this is the correct way of writing. So this means, now what does it mean? That AB side is proportional to PQ, right?
Yeah.
Okay. And then BC is proportional to QR, that you can check here.
Yeah.
Yes. And this AC is actually proportional to PR. So that also you can see here. So this is
Yes,
the
ma'am.
correct way of writing. Understood?
Yes, ma'am.
Okay. Now, oh, what is happening to my screen? Okay, let's come to exercise 6.1.
Yes, ma'am.
Do you have the book with you right now?
Yes, ma'am.
Okay, tell me. Fill in the blanks. All circles are. What
One
should
minute,
be
let
there?
me open. Yes, ma'am.
All circles are. What should I write here?
Similar?
Why? So why are you not very sure about it?
One minute. Is that the right answer?
Yeah, it should be. Yeah, it is right answer. But I mean, please explain it a little bit. Why do you think it is similar?
Because they're circle in shape. They're like full round.
Yes, see, he is saying all circles. So circle, it's not necessary that they are same in size, isn't it? I mean,
Yes,
this
ma'am.
is circle, this is a circle. But if this is circle and this is circle, so they are also circles. So you can compare any circle with any circle. So all circles, since he is talking about, so obviously we will write similar. So similar means the shape is same shape, right?
Yes, ma'am.
And because they all are circles, so same shape. So obviously, they are similar. Okay. And the second one, all squares are
Similar
again. Yeah, because
same shape.
shape is same, but we don't know about the size. Third one, all dash triangles are similar. Okay, what is an isosceles triangle?
Whose all sides are equal.
And what is an equilateral triangle?
Whose one side is
One side equal, I mean, there's nothing like that. Either we talk of two sides equal, or no side equal, or all the sides equal.
two sides equal.
So which triangle is that?
Equilateral is two sides equal.
Oh no, Sarah, equilateral. It's clear from the mind. Equal,
All
coming
sides
from the word equal. Yeah, all sides are equal. So equilateral means all sides equal.
And then why are they different? Like isosceles also.
Yeah, isosceles only two sides are equal. I mean, the triangle can look like this. Obviously, the two sides are equal, but the third one is not equal, right?
Yeah.
Yeah, it is. Let's say this is 5, and this is 3. So this is an isosceles triangle. So two sides equal, but not the third one. So somewhere you can make a box and you can note it down in case you are forgetting. Two sides equal. Because these words keep on repeating in the questions. Okay. So all dash triangles are similar. Which one should I use? Equilateral, obviously. The size can vary, but the shape will always be same. Second question. Give two different examples of pairs of similar figures and non-similar. Okay, I start with non-similar. Tell me two non-similar figures. Okay, what is the definition of similarity? Same shape, right?
Yeah.
And if the shape is not same, so non-similar. So can you give me example?
When the angle.
Different shapes. You mean you have to choose different shapes now, right?
Yeah.
So you can take, one circle and one square, isn't it?
Yeah.
So this is one example. Okay. Another example.
two triangles.
But they both are triangles.
Yeah, but having different
sides.
angles.
Yeah, you can either say isosceles triangle and equilateral triangle.
Yeah.
And equilateral. Okay, then it's okay. But you cannot write two triangles. Okay. So one is isosceles, one is equilateral. That means different shapes we are talking of, right?
Yeah.
Okay, that's good. Now come to similar. Can you give me two examples of similar figures?
Square.
Is square, but if I write simple square, so yeah, I mean, write it a bit properly, like two squares. Basically, you are giving examples. So two squares, like of sides. Let's say one square is having side 2 centimeter and another is having 4 centimeters. So then both the squares are similar. This is one example.
Yeah.
Can you give me another example?
Two triangles of side 5 centimeter and 2 centimeter and 10 centimeter.
Okay. So you cannot simply say triangles, then say two equilateral triangles. Otherwise, you have to give dimensions of all the three sides. Yes?
Yes, ma'am.
So two equilateral triangle means all the three sides are obviously equal. Of sides 2 centimeter and 10 centimeter. Yeah, this is good. Now come to third question. State whether the following quadrilaterals are similar or not. What do you think, Sarah? Okay, what is the criteria for similarity? What are the two criteria?
First of all, angles should be equal and sides should be proportional.
In same ratio. Yeah, in same ratio.
Yeah.
Okay, so first criteria, if we talk of here, the angles. So do you think angles are equal?
No.
Yeah, definitely, because see, one is 90 degree each straight. It is also, sine is also given. That means every angle is 90 degree. And in the other one, the other shape is like this. So you can see this angle is less than 90 and this angle is greater than 90, isn't it?
Yeah.
So obviously the angles are not equal. So you will write, since angles are not equal, so the quadrilaterals are not similar.
Yeah.
Or you can see like which way the answer is given in the NCERT accord, like that you can write. Just a minute, let me check. Oh, they have simply written no as the answer. Anyway, you can write a line that since the angles are not equal, the corresponding angles are not equal. Write it like this.
Yes, ma'am.
The corresponding means this one, like S is not equal to D, right? R is not equal to C. Corresponding means this. So corresponding angles are not equal. So the quadrilaterals PQRS is not similar to
ABCD.
Yeah, is not similar to ABCD. Yes. So quadrilateral, sorry, is not similar to quadrilateral ABCD. So write properly.
Done.
Okay. So first exercise was easy. Basically, it was about the definition of similarity. Getting it?
Yeah.
Okay. So, I mean, this point has to be very clear that what is the meaning of similarity? What are the two criteria which needs to be fulfilled? Now, the second exercise is actually based upon a theorem, which is called the basic proportionality theorem of similar triangles, basic proportionality theorem. So first of all, we will try to prove this theorem. Sometimes the proof is also asked in the exam. So write down the statement, then we will prove. okay, the name of the theorem is actually this, basic proportionality theorem. It is also called as Thales theorem. So the statement is this, then I'll explain. First you write. If a line is drawn parallel to one side of a triangle to intersect the other two sides in distinct points. The other two sides are divided in the same ratio.
I'm done.
Okay. So now let me explain what is the meaning of it. It is saying that if you have a triangle, right? First understand, don't write. If you have a triangle, sorry, it's such a bad triangle anyway. Let's say ABC. Now, if I'm drawing a line, let's say I'm trying to drawing a line like this, which is parallel to BC, right? Now, this line is intersecting the other two sides at distinct points. So it is intersecting it here and it is intersecting this one here, right? So I just call it, for example, DE. Getting it?
Yes, ma'am.
So the line is actually, it was parallel to BC. So this is how I'm drawing my line. So D is actually parallel to BC. Now, according to the theorem, what is the meaning of the theorem is that if this line is parallel to, third side BC and cutting the other two sides in 2 points, then they are in proportion. So AD upon DB. That means, this much part upon this much part will be equal to this much part upon this much part. So these will be in the same ratio. Understand?
Yes, ma'am.
That's it. That's the theorem. So we will try to prove it properly. So just draw a proper figure and we will show. Okay, let's take a triangle. ABC. And then I'm taking the line here, which is DE, right? DE is the line which is cutting the triangle at two distinct points. Okay, so what is given here? A triangle is given, which is ABC. And it is also given that the line DE is parallel to BC. Clear? Okay. And what you have to prove?
Ma'am, can you?
Yes. Say, Sarah.
Can you slide down a little? I can't see that.
Okay. I'm sharing my whiteboard. Is it clear? Is it visible?
Yeah, but can you slide down?
Wait. Oh, it's actually whiteboard. Oh, just a minute. Let me reuse my OneNote. Yeah, is my screen visible now?
Yes, ma'am.
Okay. So again, this is the triangle I was using. ABC, right? Okay, and
Yes,
that's
ma'am.
my line DE. Okay. Now what is given here? It is given You are given a triangle ABC, and this is also given that the line DE is parallel to BC. Okay, now what you have to prove? To prove that AD upon DB is equal to AE upon EC. So please see in the figure what is AD, what is DB, what is AE, what is EC. Okay, we will do some construction here because I want to use some property of triangles and I am not able to see many triangles in this figure. So I'll just break it into triangles. So I'm just, joining these 2 points and this. Clear? So this is one construction, that join BE and DC. Clear?
Yes, ma'am.
Okay. Now another construction is that I'll drop a perpendicular here. Perpendicular means that this angle is going to be 90 degree, right?
Yes, ma'am.
Okay, and I'll drop another perpendicular here. So this angle will be 90 degree. So give it some name, F and G. So draw EF perpendicular on AB. So this is the sign of perpendicular on AB, and DG perpendicular on AC. Is this clear?
Yes, ma'am.
Now let's do the proof. Okay, so the proof is simple. First of all, we will look the triangle from this side, and the second one, we will look the triangle from this side. Understood? So let us look
Yes,
from
ma'am.
this side first. So like you can start looking from this side. So AB is actually now my base. So I'm looking at this way. So I'm working on my line AB. So on line AB, let's check on this. So if I take triangle ADE, now see which is ADE, the top ADE, the half triangle, I mean the top one. Yes?
Yeah.
ADE. Okay. So I want to write the area of this triangle. What is the area? Area of triangle. This symbol is for area. Okay. Area of triangle ADE. So what is the formula? Area of triangle, half base into height. Yes.
Yeah.
Okay. So half into, what is base? Because I'm looking from AB side, so the base will actually be AD. Yes, of this triangle. Yes, Sarah?
Yes, ma'am.
See, this much triangle I'm looking at, this much. Okay. Okay. So I'm looking from this side. So this is my base and this is my height. Clear?
Yeah.
So AD is my base and my height is EF. Yes?
F.
EF or FE. Yeah. So this is my equation number 1. Okay. Now I'll take this triangle, the lower one, this one. Getting it?
Yeah, ma'am.
Okay. So area of triangle DBE, let's say. Again, half base into height. Clear? So half base. Base is how much? DB. Yes?
Yeah.
Base of the triangle. And what is the height of this triangle? Can you tell me?
DC.
DC. No, no, no. This C is actually outside this triangle, right? The C is
Yeah.
not a part of this triangle. See, Sarah, if you look it from this side, this triangle is actually like this. If I just shift it, this is my point D, this is B, and this is your E. It actually looks like this.
Yeah.
Yes. So
Yeah.
the height is always at 90 degree. So in such cases, we just extend this line and then we drop a perpendicular here, and this height we actually take in calculations. Getting it?
Yeah.
So the height will actually be EF. Understood?
Yeah, ma'am.
So you can, draw, you can just, as a side note, you can draw this figure so that it, it will be clear to you in your mind that what
Yes, ma'am.
exactly you are doing. So this is actually, height h in this case. So this is equation number 2, right? Now just divide these two equations. Equation 1 divided by equation 2. So divide equation 1 by 2. So that means area of triangle ADE divided by area of triangle DBE, right? This
Yeah.
is equal to half into AD into EF and divided by half into DB into EF. Clear?
Yeah, ma'am.
Okay. Now this half will be gone. Yes. I
Yes.
mean, this half will cancel out. Similarly, EF cancel out. So what you are left with, only
AD by
AD upon DB. Yeah. So this result, I'm just giving it my result. I think, what can I say? Third. Let's call it my third equation. Yes.
Yeah.
Okay. Now the same thing. These two steps. I'll do again, but I will look at my triangle from this side now. This side. Oops. Getting it?
Yes, ma'am.
So from this side, I'll see. So that means this time this will be the base and this will be the height. Getting it?
Yes, ma'am.
And then instead of this triangle, I'm going to use this triangle now. This one. Understand?
Yes, ma'am.
So first, I mean, these two triangles and then these two triangles from that side. So I hope you have drawn the picture clearly in your copy.
Yeah.
Don't mess it up like me. Now start looking from the other side. So on line AC, let's work out on line AC this time. Okay. So again, you write area of triangle. What was the triangle then?
Mm.
ADE, yeah, the top one, ADE.
Yeah, ADE.
Okay. So what is the formula? Half base into height, half into. So base this time will be how much?
One minute. GD.
No, that is height. Base.
1 minute. AE.
AE, good. So because I'm looking from this side, right?
Yeah.
And then height is DG. Okay, that's good. So again, because I want to divide, so I have to give some name. Let me call it 4. Yes. And then again, the lower triangle. What was the name of the triangle? DEC, I think. DEC. Yes.
Yeah, DEC.
DEC. Okay. Again, half base into height. Half into what is the base?
EC.
EC. Good. What is the height?
GD.
GD. Yes.
DG.
Yeah, DG or GD, same thing. Fine. So let me call it 5. Now I'll divide 4 by 5. Same steps I'm doing, right? Just on the other side. So divide 4, equation 4 by equation 5. Okay. So area of triangle ADE and divided by area of triangle DEC. Okay, so this will be equal to half into AE into DG and divided by half into EC into DG. So again, this half will get cancelled out. DG will get cancelled out. You will be left with AE upon EC.
Yeah.
Equation number, no, I think 6 this time. Yeah.
Yes, ma'am.
So ultimately, these are the two equations I'm interested in now. So these are the results I've got. Now you can see one thing, Sarah. Ultimately, I have to prove, see the to prove, what I have written to prove.
AD by DB.
So basically this term, right, is
Yeah.
equal to this term that you have to prove. So somehow if I prove that the left hand side is equal, so ultimately the right hand side will be equal. Clear?
Yeah.
Okay. Now look at the left hand side. Here what I have ADE and here also I have ADE. So this is equal. Yeah.
Yes.
Now look at the denominator. Here is the difference. I have DBE here and I have DEC here. So these two triangles are different. I mean, one is the left one is the right one. Clear?
Yeah.
In the figure. Somehow, if I prove that the area of these two triangles are equal, then my left hand side will become equal. Clear?
Can you say again?
Yeah.
Can you say again what you said?
Yeah. So basically, these are the two triangles. I mean, they are basically these two triangles. Sorry. If you look in the figure. Yeah. So basically, this was my figure. Clear?
Yeah.
A, B, C, and this line was your DE, right?
Yeah.
So DEC, that means one triangle is this one, and the other triangle is this, BDE, these two triangles. So here is the difference, DEC and clear?
Yes, ma'am.
Yeah. So somehow I'll try to show that the area of these two triangles is equal. So my left hand side will become equal, right?
Yeah.
Ultimately, this will become equal to this. Numerator is already equal. So my LHS, both LHS will be same, and ultimately I'll get my result that my RHS is same. So let's try to show that the area of these two triangles is actually equal, and we will make use of one theorem which we have studied in class 9th. Now come back to the theorem now. So let me just explain, don't write. The theorem was actually this, that if you have, let's say you have two parallel lines, right? Yes. And you take some base, let's say from here to here, I'm taking some base, clear? AB.
Yes,
Now I can draw so many triangles with the same base like this. For example, this is one triangle I'm drawing. Yes.
yes, ma'am.
This is another triangle I'm drawing. So one triangle is, you know, APB, one triangle is AQB, and I can draw the third one also, ASB, or anything you can like. So many triangles you can draw. Basically, infinite triangles, I think, can be drawn. Clear?
Yeah.
So all these triangles will have the same area. That is the theorem. That if the triangles are actually lying between two parallel lines and they have a same base, so all those triangles will have the same area. That's actually a theorem. Yes, it is already
Yes, ma'am.
proved. So we will use this theorem here now. So you will just write down this statement of the theorem. So I hope it is clear in your mind.
Yeah, ma'am.
Okay, so write down the theorem that okay, write it like this now. Your triangle BDE, which actually are the problem triangles. Now triangle BDE and triangle DEC, you know, these are the two problematic triangles, okay, are on the same base. Same base, DE. So DE is the common base of these two triangles. Yes, see in the figure.
Yeah.
Okay. And between same parallel lines. Now, what are the parallel lines? It is given that the line DE and BC are parallel. Yes.
Yeah.
Okay. So therefore, the area are same. So therefore, area of triangle BDE is equal to area of triangle DEC. Yes.
Yeah.
Okay. So we can substitute here. like in equation number 6, so in place of DEC, I can now write BDE. Yes.
Yeah.
So from equation 6, this time area of triangle ADE and divided by area of triangle. So in place of DEC, now I'm writing BDE. Okay. Is equal to AE upon EC. So basically, I have converted my equation 6 into this. Let me give it some name, because now I want to compare this equation 7 with the third one here, right?
Yeah.
So now compare third and seventh. So LHS is same, both the case. Numerator was already same. On the left hand side, if you see, numerator is already same.
Yeah.
And denominator now same. DBE or BDE is the same thing. Basically, we are talking about the area of triangle. Yeah.
Yeah.
Okay. So left hand side is same. So ultimately the right hand side is also same. So are you right?
Yes, ma'am.
Comparing equation, or from equation, you can say from equation 3 and 7 now, and equation 7. Now the RHS is same. So your AD, sorry, what was that? Yeah. Third equation means your AD upon DB,
yeah,
is equal to 7th is AE upon EC, and this you were supposed to prove. Understood, Sarah? I think
yes,
this was
ma'am.
not tough. Yeah. Now every theorem has its converse also. Converse means see, Sarah, in your previous classes, I think you have done these kind of things that, for example, you have two parallel lines, right? And then there's a transversal which is cutting it. So that means if this is your line L, this is your line M. So if, transversal is cutting it. So if, if line L is actually parallel to line M, if they are parallel lines, so that means this angle 1 is equal to angle 2 corresponding angles.
Yeah.
So angle 1 is equal to angle 2 corresponding angles. Now converse of this is this. Converse means same figure, but it is not given that the lines are equal. Okay. Sorry, lines are parallel, not equal. So it is not given that the lines are parallel, just a figure is given, but it is given that angle 1 is equal to angle 2. So the converse is this, that since the angle 1 is equal to angle 2 and they are actually corresponding angles, right? So since corresponding angles are equal, therefore the lines are parallel. So it's just the opposite of that. Understood?
Yes, ma'am.
So similarly, what will be the converse of BPT? Basic proportionality theorem was that if you have a triangle and then this line is actually parallel to this line. Yes.
Yeah.
So DE is actually parallel to BC. This is A. So it was given that sorry, let me write it properly. Write down the converse of BPT, because you will use this result also. Converse of Thales theorem. Converse of Thales theorem is this. This is the triangle ABC and this is DE. So this time actually the ratio will be given equal. So AD upon DB is equal to AE upon EC. Clear?
Yes, ma'am.
Okay. And the result will be that the line is parallel. So DE is parallel to BC. Getting it?
Yes, ma'am.
Converse means the result of the theorem is now the given condition, and the given condition of the theorem is actually now the result of it. So the opposite way you will use it. Understood?
Yeah.
Okay. So let's take, I think, one question from the exercise also. We have time. 6.2, please look at exercise 6.2.
Yeah.
So in the figure, I'm drawing the first one. That's something like this. And then there's a line DE. And this is ABC. So some are given 3 centimeter, 1.5 centimeter, and 1 centimeter. Okay. It is given that DE is parallel to BC. Clear? Find EC. EC you have to find. Now this is sorry, something happened. Are you able to see now, Sarah?
Yes, ma'am.
Okay. So Sarah, this is given now that DE is parallel to BC. So you can use the basic proportionality theorem, isn't it?
Yeah.
Okay. So since DE is parallel to BC, okay, then applying Thales theorem. Now it's actually called Thales theorem. Thales theorem. So AD,
Ma'am, first
yes.
we have to start from in triangle ABC, right?
Yeah, oh, sorry. In triangle ABC. Yes, that's good. So in triangle ABC, I'm actually using Thales theorem. So DE is parallel to BC. Now, so that means AD upon DB is equal to AE